This is proglangcast. I'm one of your hosts, Christopher Augustus. The other host, Steve, is not available this week, and neither of us were available last week because I had to move. I'm still moving from one end of Portugal to the other, and Steve was away, and he's not back yet. But he'll be back next week. And instead of covering Bye Bye Hello World with F#, I will be showing the versions that I've done in Scheme, Shea Scheme, Racket, and S7. But we're not going to do that this week. This week, we're going to revisit a lot of cool stuff from last week, which was the APL version of Bye Bye Hello World with a little bit of preview of extra credit of BQN. We're going to dig into BQN at the end of this. But first, let's go back to the screen, and I want to show a great video that Adám Brudzewsky, hopefully I'm pronouncing his name correctly, from the APL cast, did a reaction video to our video with our fledgling attempt, my fledgling attempt at APL. This is a great video. You can see it here on YouTube. He's got it on the dialogue site, and I'll provide links to this. It's last week also provided links. We did our video. He did our video afterwards. And we'll come back, and we're not going to do a full reaction here, but I'm going to highlight some of the points of where he showed the lackluster things that I did in the GNU APL implementation and showed how much better both dialogue is at doing this, and of course he's a masterful APL person. I think it would be great to have Adám do an interview with him at some point if he's open to that. Hint, hint. And but in addition to that, the ArrayCast folks did a shout out for us, which was unexpected, and I'm quite honored. That was on their latest episode. What is their latest episode? Henry Rich and the RISA J95. So I want to thank Bob in particular. Bob Terrio? Should be Terrio. Is that French Canadian? Sorry, my French isn't that great. Neither's my Portuguese, but I'm working on it. And of course, I want to thank Adám for the great work he did on showing us better ways to implement this in his own video, and the other hosts as well, Connor, of course, who's led me back into the world of array programming. I probably would not be back at APL, even though Steve called me out on it, if I hadn't been following Connor's journey into it a couple years ago and the beginning of the ArrayCast. And Marshall, of course, Lockbaum, the creator of BQN. We're going to have more to talk about that. I'm very interested in this language for my own selfish purposes. So we'll get into that a little bit. But let's go back to Adam's response, and I want to show his code as well. But before I do that, there's one other. I was just re-listening today to an older ArrayCast episode. This is episode 32, I believe. It doesn't have the numbers on it, but it goes back to July. This is just after their first year. They did a first year, which I think is episode 30. Probably be easier to see if I go back to all of them. But it's called Control Structures in the Array Languages, which is, it's funny listening back to that. I really should have listened to this episode before doing my work on the APL because it so directly applies to the version of Bye Bye Hello World that we did. I keep saying we, I did in GNU APL. Because one of the things I pointed out last week is how this really isn't the ideal APL program because it involves sort of an imperative control flow with a lot of back and forth. And this whole episode at the ArrayCast talks about control structures and how to do them in the various APLs, a lot of which Adám addressed in his dialogue implementations. So it would have been very helpful to listen to that, re-listen to that, and it's great. So I highly recommend that along with all the other episodes. So actually, let's leave this up here. This was my attempt at an APL solution for Bye Bye Hello World, which we talked about last week. And then Adám, in his video, which we could play the beginning of it. Let's go from the very beginning.
Hi.
There he is.
This is a response video to a recently published video where a couple of people are
Yeah,
exploring a little bit
I'm one
in
of the couple
APL.
of people. As Bob pointed out, we didn't introduce ourselves in the videos. We haven't done that at all in any of the proglangcast videos so far. That's my fault. I have this kind of issue with notoriety. I want my words to matter because of the content and not because of who I am, but I'm just weird that way. And I subjected Steve to that. So we'll let Steve introduce himself next week and when he's back. But I want to jump ahead. He just kind of covers the premise, and but what's most interesting here is he points out where we kind of went out of our way to do things that we didn't need to do. Unfortunately, kind of halfway through the video here, Adam's camera seems to shut off.
As long as there's any zero
we
in
have
this.
his voice.
Of course, if it's empty.
But we don't. We lose the animation of his face. The curve converting the string to the number. So this is kind of interesting. I thought I was rather clever in coming up with this way of taking the input string from the user and converting it to a number with these two expressions. The first here, which simply validates that it's in fact an integer number containing only digits, and then it does the actual conversion to an integer value down here. Points out a couple of levels at which a lot of the code here is unnecessary, and in the end, all of this code is, for the most part, well, at least the second expression is entirely unnecessary. And may try that in GNU APL here and see if we get the same result as he did with dialog. But let's take a look at what he said here really quickly.
And this is where things get a bit interesting, because we want this, the count, but we want it changed into a number. And in the video, then it's kind of clever what they do, but it's completely unnecessary. So here's an interactive APL.
I have to say, I love how polite he is about that. It's kind of interesting, but unnecessary. Thanks for being gentle with that critique.
Sessions or a REPL, and what they do, let's say we have the characters 1, 2, 3. That is, they want to get digit values for these, and they do that by taking the Unicode value of the characters. So that's this, and then they have the Unicode value of a 0, and they need to subtract that. Like that. So that gives us the individual numbers 1, 2, and 3, and then they construct the number. They need to they reduce on it, so they need to do it in reverse because we start reduce from the right. And what they do is they take the previous value and then they add it to the next value, which is multiplied by 10. And that gives us the number. And this...
I just want to note that my lameness in out these parameters, I should have known. I mean, I know this is an alpha and omega. I kept saying W because, of course, English speakers tend not to use the Greek alphabet, so we see that as a W and maybe that as an A. But this, of course, alpha first letter, omega last letter, the left argument, the right argument, to this defense. And to that point, when I was struggling to try to figure out what to call the inverted delta symbol, where is that inverted delta? Here it is. It's called del. And simply by using try APL or actually going to the APL wiki and reading any of it, you could see the names of all of these. So I have no excuse. Up style. Oh, that's interesting. This is down style. Okay, I knew that. I think this one's called shoe. Left shoe. Yeah, left shoe, right shoe. At least I knew quad and squad. Well, that's a different one. Quad's not quite in here. Anyway, tryapl.org, provided by Dialog, a great interactive online, do your APL and learn how to use it. Highly recommended. For BQN, there's BQN pad, which is also really awesome. Back to the video. Let's continue as he shows how this work right here is completely unnecessary.
And this is very clever usage of APL, but it's actually completely unnecessary. This whole thing here with the reversal, that's actually a base evaluation which APL has built in and has always had built in. So in fact, once we've got these numbers 1, 2, 3, we can just evaluate that in base 10, which now it's been reversed. We don't want to reverse that anymore. So evaluate that in base 10. We can use this to evaluate in.
So let's jump into that and try that. Let's actually try that in GNU. Now he's using dialog. Let's try what he just suggested. And I think I have to cheat here because I lazily still haven't installed the necessary APL keyboard. So what I do is I use this this debug version over here. It has a copy of the keyboard in it. And we're going to use this thing that looks like an upside down T. Where is it in here? We'll come back to that. There it is. Let's just do a copy of that. And what did he say? Put it after the 10? Oh, it didn't quite copy. Let's try copy and copy. I should probably just copy the keyboard straight in. There it is. So if we take this expression, so it looks like we still need the defense here. Let's see the way that Adám did it. Let's see. Yeah, he's still got that. And what is the name of that? That is called uptack. Yeah, it looks like a tack. Uptack. So I'm guessing the other one is downtack. Downtack, uptack. All right. Sorry for the bright white here. Should go dark mode on that. Let's go ahead and go to GNU APL. So we've got the dialog ones in here, and let's try run. See if it works. Okay, 10. That's interesting. Did I say 10? So we still have this problem of not echoing input. I haven't gotten around to figuring out how to do it. So let's say 3. 3, 2, 1. Okay, so the number conversion seems to work. Let's try a multi-digit number. In fact, let's just do this at the command line. Let's go 1. Let's go XX. Yeah, so it's catching our countdown, and I'm going to do this so we can actually see. Let's say 11 seconds. Actually, let's do 565 seconds. It's going to keep going, obviously. Okay, so he's absolutely right. That works in not just dialog, but also GNU APL. So we're going to save that. And, oh, that is very bright. Let's continue on as he shows the rest of it is also useless.
Any base. But even finding the digits like this, the digit values, is also unnecessary.
Yeah.
Firstly, we could just look them up in the list of digits. Then they're off by 1, but we could adjust that. But remember, at the point when we are ready to convert from text to numbers, we already know that we only have digits and we have.
All right, so first let's see if GNU APL has this same quad digit function. I think I'm going to have to copy it. Again, not having the keyboards. We're just going to have to copy that quad in. And let's see what expression he used again. He said D with iota. No, it looks like iota, right? Is that iota? But iota usually takes a number and produces an array. That's interesting. It's iota, right? As a monadic function, is this a dyadic? It's an index generator. As a dyadic function, it says index of. Oh, I'm kind of a little stumped on how that's working. We've got a string, which is an array of characters being passed to iota, and dash D on the left, but that's a function. Well, anyway, let's see if it works. I think I have an iota in here already, right? Yeah, right there. Actually, it's fine. I know this is so terrible that I'm doing this this way. Whoa, okay. We're going to copy the iota in. And he just said, quote 1, 2, 3, right? Quote 1, 2, 3. Quote 1, 2, 3. No, it doesn't look like this quad D is part of GDU APL. Maybe it's quad digit or something else. So that is uniquely a dialog function, I assume. I think we'd see it in here. Somewhere in here, probably. Quad D, there it is, digits. Yeah. This is a simple character vector of the digits. Oh, I see. I see how it works. Okay. So this, we could do it by not using quad D, but using a binary form of iota here, right? 0, 1. That's what it's going to do is provide us indexes of that number. In fact, let's not say 2, 1. Let's do, oh, I don't know, 5, 7, 3. Got it. Huh, interesting. Okay, let's just listen to him continue.
Have digits. It's not empty, which means we can simply evaluate.
-1, so it's off by 1. Oh, because it's the index of each of these into that array off by 1. So he takes a -1 and subtracts, and we're going to get 5, 7, 3. Of course, that makes sense. -1 plus, I could probably do a flip and use a minus, but it makes sense that he's using -1, which I think I have in here somewhere. Yeah, there's a -1. Yeah. So let's see if I can insert that. Can I insert that? Yeah, and then plus, that produces separate digits. As he shows here, how do you then turn that into a single integer?
This character vector as an APL expression, because the characters 1, 2, 3 evaluate to the number 123. And there is a primitive APL function for that. It's execute, and that just does the trick.
Okay. Well, I'm not going to see how we put these together to form, because this is not a single scalar integer. This is an array of individual scalars of index values. So we didn't really see how, if we weren't going to use execute, how we would take that and collapse it into a single integer value of 123. I'm sure it's a straightforward thing, but I don't want to belabor too much time on it. But let's see if we can use execute as he was saying. In fact, we should be able to copy it from here. And it's this thing called thorn, or is thorn the upside down one? Hydrant. Yeah, it looks like a fire hydrant. I think the top one is called thorn. Yeah. And hydrant is just an executed. Basically, it's an eval, like you would see in many other interpretive languages where you can provide a string and it acts on itself as if it's a literal expression. You can do that in Erlang. You can do it in Lisp. So let's try that and see if GNU supports that. If that supports it, then that'll be a much better solution. So let's try that. 1, 2, 3. I'm sure it's going to work. 1, 2, 3. The integer scalar value 1, 2, 3. Okay. Let's minimize this here. Let's go back to, I don't think I need the keyboard. Get rid of that. So what he was showing was really this entire expression here is unnecessary. Oh, we lost the hydrant. Right, we have it. We have it here. Actually, can I do a control copy and paste from there? Oh, I can. Okay. So Z becomes hydrant C. Now, he's going to point out in the video, rightly so. Let's go back to the video. Sorry, my overlapping windows. Wow, that bright white. Okay. He's going to point out that this isn't necessarily a safe operation, because if this is not a convertible number, well, let's hear what he says.
So that's what we're going to do here. Which means we can simply evaluate this character vector as an APL expression, because the characters 1, 2, 3 evaluate to the number 123.
Right.
And there is a primitive APL function for that. It's execute, and that just does the trick.
The fire hydrant.
So that's what we're going to do here. It's normally not a safe operation to have like an eval inside your code, but in this case we know that it's safe because we know we just have digits.
Exactly. Which was the same logic that was there before in terms of safety for doing the conversion. I keep having these windows not in a way overlapping. I'm really thinking switching to tiling window manager. This is on Mac. Pretty soon I'm going to get off of this and just be doing everything from Linux. But to his point, if you just did an execute on an expression and it had invalid syntax for APL, we would append here, or we'd be interrupted. It would be an error. But we know because we've structured this. I keep saying we. It's just okay. I structured this in such a way that it would verify that these are all digits. So this should be a completely safe operation, which he's pointing out as well. And yeah, so let's continue on with that. So anyway, I don't want to spend too much time doing a full reaction on this. I highly recommend people just watch this. It's a great video and the work he did. But I do want to walk through each of his 4 solutions. Right, if you want to see the details, you don't really need my commentary. It's not adding a lot of value here. Let's take a look at the 4 solutions that he provided. And I'm going to get rid of actually, let's keep the GNU one up here so we can see. Here's the GNU. Now, his are dialog, and they are now added to our repo, which is Bye Bye Hello World on GitHub, which I'll point out. And I want to thank Adám again for doing this, doing these 4 different variations on a dialog APL solution and showing us the difference here. And he labeled these as 4 different variations, kind of starting from one that looks closest to what he's calling here the structured version, closest to the GNU APL implementation. So you can see it matches pretty closely. The difference is he's got legitimate control flow, I don't know what you call these operator statements. They're statements in dialog. I don't believe that GNU has anything equivalent to that. It's limited to the conditional with the jump, the row symbol here makes this branch to this label. This is kind of the whole go-to situation, whereas here you've got block control structures. But other than that, it's somewhat similar. He also made more extracted independent functions for the logic, so you could see the entire program statement executing essentially on a single line here, which this implementation was more script-like without making separate functions. So here's the structured approach. And then in the next version, he has the defense, in which we can see, rather than using, I think what they call trad-fin or traditional function notation, this is with the del. This is declaring a traditional function. This is the end of the function declaration. I think the del is also used to do recursion. So if there's going to be recursion within the function, the del would be used to do, in fact, maybe that's only in the defense. I think that's what we're seeing here. We're seeing here the del is used as the recursion call to the function or the defense, the direct function. So these are traditional functions, trad, fn, and these are direct functions or defense. In other languages, we would simply call them anonymous functions, lambdas, or closures. So this is essentially the same logic in his defense variation, not using the traditional function, but using the defense. So we've got less code, we've got more concise, which is, in my opinion, always better. And then he has a balanced here where there's some use of defense. So we can see some sub-expressions within here are defense, but he's still keeping to the traditional function declarations here, or definitions here. So really we're kind of going from this is the most code to the balanced is less from the use of some direct functions to all direct functions here. And then the final coup de grace is the fully inlined single line no use of branching, no use of traditional functions, and I'll put it onto a single line, which ends up being, if you don't count the comment, 163 characters. So that's a little bit over my limit. I tend to like to keep my lines to 80 columns. But I respect this. I like, I'm a big fan of tacit, even prior to coming back to array languages, or I should say coming back. Obviously, in the last video I pointed out, it's only when I first started programming as a kid that I programmed an APL, and I quickly drifted away from it. But in other languages over the years, I have formed a strong desire for more tacit code in all the code that I write. I'm pretty allergic to boilerplate and excessive verbiage in the code that I read. So I'm drawn to symbolic programming and reduced programming. I think it's one of the reasons why I was really attracted to the work that Connor Hoekstra was doing. I think I first came onto his code report YouTube channel because he was reviewing a set of programming languages all at the same time. And thrown in there was APL and his enthusiasm about how beautiful and expressive it was, that something could be done in other languages with so much typing could be done in literally a few characters in APL. And that kind of, I remember the days when I did APL a long time ago. So I've kind of followed him on this journey, and I have a similar draw to very concise, very terse code, and in particular tacit programming. We're seeing the ultimate expression of that here. The only words we see here are the words that need to be shown to the user in English, right? If we localize this, it would be something else. But other than that, I guess a couple of characters for some built-in functions here. This is the delay function. This is great. This is fantastic. So again, Adám, I want to thank you for that. And this is great. So let's close out. Actually, yeah, let's keep the GNU one up simply because I want to compare it to the BQN solution. I don't know if we want to compare Adam's implement. Well, we'll leave them up. Let's just leave them up. We may come over to that. But let's take a look at the BQN solution. And let's go ahead and turn off our GNU APL. And there's BQN. And I might actually already have this open in a window. I think I do. But yeah, I could see it hiding there. There it is, BQN. All right. So when I last pointed out that there was a flaw, not a flaw in BQN itself, a flaw in my coding of it, that I was able to replicate everything that the APL solution did, essentially satisfying the spec for Bye Bye Hello World, except for the fact that when I'm outputting to standard out, we're getting line feeds every time when we don't want them. And I just happened to pop over, not just before we started this, where's the other person out there? Right there, I jumped into the APL farm, the BQN channel, and asked, is there a way to call out show or any other IO to standard out without producing a new line? Because I did check the documentation on BQN. See if we can bring that up. Specification here, we've got input and output system functions described. So we've got out, show, and it says right here, out prints the standard out with the trailing new line, and show, as it turns out, did the same thing. So I simply jumped into the BQN channel on the Discord server for the APL farm, asked the question. Zyma immediately said, yeah, look, in CBQN, there's a term out raw. And I happen to be using CBQN. This is exactly the implementation we have here. On our run script, if we notice our run script, even if you don't have it installed, it will go out to GitHub and pull it down and build what you need to run and then run it directly. I'm using the fork that I have on a Boalang, but this is the same CBQN from Zyma. So great, that worked out great. And testing it, let's close that out. So I went ahead and changed this first one was an out. So now it's term out raw for the countdown because we want We don't want a line feed here, we want the input. And as it turns out, when we do this, let's do a run. It worked. We don't have a line feed anymore. Now, we still have a line feed in another place we don't want, which is when we're actually outputting it. We don't want the line feeds there. So we can get rid of this. That works. Invalid countdown, I think we do want the line feed. But here we want to use this term out raw. So, yeah. So we'll just copy that. Yeah. Yeah. We'll just type it. Term out raw and term out raw. So I don't know if this would be an issue. I didn't ask if you were using a different implementation of BQN versus the CBQN. I believe Zyma has one written on Java, and Marshall's actual BQN, which is self-hosted in BQN, but requires a platform, a smaller platform for his hosted interpreter compiler to run on, which is essentially what CBQN is. Right, CBQN still uses the self-hosted BQN compiler provided by Marshall in the BQN repo, but CBQN provides that minimum runtime platform that's needed for the hosted interpreter and compiler to work, and it's written in C. That's why it's called CBQN. And Marshall, I believe, I haven't tested it, but I think he has a JavaScript-based platform for that. Let's go ahead and run this and see what we get. So let's put in the wrong countdown. Oh no. Yeah, we do want just the regular out there because we do want that new line. But this time we're just going to say 4. Okay. I see what's happening here. We did want a new line on the last one. Okay, so I've seen this elsewhere, not just in the APL implementations, but this out raw, as Zyma described it, since standard input and standard output provided by operating system or by the libraries that are sitting on top of the operating system, standard input and standard out is mapped by programming languages, is typically buffered, and there are ways to turn that off. In some languages, there are global switches which you can go unbuffered, but usually the easiest thing to do is to flush the buffer in the case in which you're not outputting something like a new line or taking input. I don't think in the case of this is necessarily, I don't know if it's the new line that causes the buffer to flush automatically on out. It's possibly a new line followed by a flush. It may also be that a subsequent input, like a get line operation, would also cause a flush because the buffers, you've got buffered output that hasn't been displayed yet, and now you're going to do input. Typical sort of implementation of a buffered I/O layer would be to flush before doing input on the same channel. Effectively, you have a standard output channel, standard input channel. But the nice thing is, if we look at the documentation for BQN, we'll see there's a flush operation. So it's flush output buffer. And we've seen this in other implementations. Back down here, other implementations in other languages. In fact, I think we can take a look at that. And the C version also does a flush. Let's take a look, see if there's some flushes in here. Yeah, there we go. So it's the same issue. In the case of typical C implementation, doing a simple printf without a new line or without taking input or without changing some global setting that would affect how buffered I/O works, it's going to sit there in the buffer before it actually sends it to the display without the flush. So it looks like we need to do the same thing here. So let's just do that. Let's just say flush here. We want to flush on that. This last bye-bye needs a new line, so we're going to keep that as out. The out raw, we want to, I think we want to do it before the delay. Yeah, we can see that's what's happening here. We print, which sends it to the buffered standard output. We flush that so we see the number before we wait. So we're starting the countdown. We're saying 3, and then we wait 2, and then we wait 1, and then we wait a second, and we don't show a 0. We just show a bye-bye for 0. So in the case of BQN, we have a sequence of separate statements. Rather than putting them on new lines, we can simply add this. Kind of hard to see what this is one of the symbols that doesn't show up too well on this particular font. This font is on Mac. I think it's called Menlo. In fact, let's see what that is. What's our font type? GUI font is Menlo. Yeah, it's a pretty nice font for BQN and APL. It looks good. It spaces well. You can see the symbols very similar. This is the one symbol that you can see is like a tiny diamond. It doesn't show up too good. In fact, let's see what the name of that is. Put on your sunglasses, bright white here. And it's a diamond. Where is the diamond in here? There it is. It's a hollow, it's a diamond. Okay, it's called a diamond. That makes sense. So yeah, this particular font, it's got a BQN pad. We can see it's also in here. Yeah, he's got the nice font right there, which shows it as the nice hollow diamond. So this website's BQN pad using a much better font for the BQN symbols here. I think we can, I think we can put this away. And let's go back to spacing my windows in a way that I can see stuff. But that is the same. This is the hollow diamond. All right, so we've got the flush. Let's just copy this, put it in the middle, and I think we'll have a, whoops. Why did it do that? That's weird. Should have pasted it right in. There we go. My Vim skills are lacking. And I think I can get rid of the comment. By the way, I really like the fact that that Marshall chose the pound for the comment. I don't want to dive in it too deep, but I have started an experimental language that may turn into a real language that I use for programming. And I also use the hash pound indicator for comments. I think it's the most used. We see it in Python. I've got in my README file somewhere. I've got a list of all the languages that use it, so that's kind of nice. And APL is okay, but it's this one is kind of funny. Not sure what it's called. Let's see. Hide your eyes. Hide your eyes. What is that guy called? Lamp. The lamp. The lamp for comments in APL. So yay, hash mark. It's better. All right. I think we have perfected at least this implementation. Oh, flush. Oh. Oh. Wow. I just bumped into a issue. Oh, it's part of term. I see. Yeah, raw mode, out raw. So Zyma was saying that out raw is specific to CBQN, but it looks like these are across all BQNs are these term operations. So we want to say term here. Term flush. Let's try that and see what happens. Read the documentation. There we go. Let's say eat is wrong. Let's say eat it is also wrong. Let's say 1, 2, 3. Huh. Well, that's kind of a bummer. Run 2. Did we not do something right, or is the flush not working? Should flush the output buffer. I wonder if it's not, this is not cooperating well with this particular out raw. What was the thing here? Raw mode, set raw mode, no input processing. I don't know if that affects the new line. Well, I was hoping we'd get what we needed here. Oh, wait a minute. This expression is going to evaluate. No, but statements execute from left to right. The expression itself is evaluated from right to left, but these statements, you know, with one line after another, top to bottom, left to right, when you use the diamond to separate. But I was thinking the delay is happening, but then we'd still see it. We'd still see a delay one, we'd see a flush, we'd see that. It would look a little weird. We're not seeing it at all until it auto flushes at the end here. Well, it's a little disappointing. Well, we'll just have to put a note in here. We'll add it to do that the flush is not really doing what we hoped it would do. Okay, to do marker. 3 hashes means needs to be fixed. Let's say flush not cooperating with out raw. Oh, caps lock. Out raw. Note that this is a BQN only, as far as I know. Should I say something about that in the, yeah, let's go ahead and ask. Simon was being really nice to answer me quickly on that. Let's say one issue seems, it seems like wash. Let's copy this. Term flush is not forcing display of the text sent to. Let me ask, is that by design? So what kind of answer we get to that? I'm not going to say cooperating. I'm just going to say not affecting. Okay. Let's walk through while we wait to see if we get a response at 6:30 my time. I don't know if anybody else is around. Let's compare the BQN version piece by piece to the GNU APL version, and then we'll be done with today's proglangcast. All right. Actually, let's go this guy on the left, this guy on the right. And yeah. So we can see a similar number of lines. Now, there's probably much more efficient ways, as Adám did for collapsed the APL version down to this. I don't know that I'd want to go all the way to a single line, but there's probably some way to get a little more tacit with some of this. I mean, I do see quite a few intermediate variables. I understand for most people, including myself, that makes it more readable. But I try to eliminate intermediate variables where I can. Also, the execute trick that was used here could probably be used. Yeah, we used it. We replaced this with the execute trick. So if we do the execute trick over here, will we get the same result and be able to collapse this down even further? Let's take a look at BQN pad and see what it says about the fire hydrant. Is there a fire hydrant here or an equivalent? I don't see it. The documentation of BQN does have a nice mapping between dialog APL and what equivalence would be in, sorry, I know this is a little small. Zoom that up for everyone. Maybe I don't know where it is, but he does have a mapping APL to BQN. Oh, he's talking about fonts a lot, which is great. There we go. BQN to dialog APL, which I think is what we want here. All right, so let's see where we've got the fire hydrant. So there's, see if we can find the fire hydrant in here. Just execute. Maybe we should just do a search. Make more sense. Let's do a search for execute. No, there is no execute. Let's try just putting the fire hydrant in. Oh, there we go. I'm looking right at it. I can't, the number of times I've done this on these videos where I'm talking about where is the thing that I'm thinking about and it's staring me in the face. It's just hilarious. Okay, so that kind of makes sense, right? The function, the monadic operator of the fire hydrant is to evaluate whatever the expression on the right is, which means in APL passing it to the APL interpreter. He's just saying, well, why don't we just pass it to BQN? Because that's what we're saying, it's a BQN. So that makes a lot of sense. So let's see if we can do that. What did we say? We can base, whoa. I almost said it, I didn't say it. I'm gonna count is gonna be dot BQN, right? Is that called a dot? What is that thing called? Is that jot? There's a jot, which is a little hollow circle. I don't think that's a jot. It could be wrong. But we want to say BQN. And is this still going to take argument on the right? Is it like that? That doesn't look. Oh no, that's right. Its arguments are just separated by white space. I'm like, duh, look it down here. Ouch. Its argument is separated by white space. So let's see what happens if we do this. Let's try run 2 again. Yep. Yepity yep yep. So same solution. Just execute the string once you know that it is in fact okay, we can get rid of the C solution. We can see that anymore. So once we know, in fact, we have the same safety here. We know that it's a digit because of the expression we've done here. So we can get rid of this. There we go, much shorter. And do we need this intermediate variable? Count input. I'd really like to get rid of that intermediate variable. Where is count used? It's used down here. So let's see. It's probably a way to pass this on through, but I think that'll have to do for now. I mean, obviously, Adám came up with a solution here in APL. I mean, we're seeing omegas, which are arguments passed to defins, which do believe, yeah, in this case, different omegas used in different places. Oh, of course, this evaluates from right to left. Gotta always remember that with array languages, these particular ones. Okay, let's just keep that for now. What was the other thing that he pointed out that we really didn't need to do? Was it the digit evaluation? here where we're using this expression to say, are you a digit? He replaced that with, see, what do we use here? Could we use one of the simpler ones here? Digit, get count. Yes, this is where, well, wait a minute. I think there's some logic here in terms of if it's not a digit. Yeah, if it's not a digit, we're going to say invalid. In our case, we're using this full expression, which is a BQN version of identical here. The only difference is where I was saying that the W's are backwards, but or let's see. I think in order to post code, put it in backslashes, backslashes, backslashes. Let's see. Can I say BQN? There's got to be a way to do this that doesn't look like garbage. Sorry to drag everybody through this, but the entire line is only displayed after by descent. Oh, okay. Let's try that. It's great. Flush, using this as like a nothing. I think it's called nothing or not. This is like an equivalent of nothing. Let's see if that works. Yes, yes. Right? Yeah, let's see. Yes, yes, yes. Yes, yes. Exactly correct. Perfectly now. All right, let's put another sunglasses. Never know if this is the right emoji. I'm not the perfect emoji guy, but meaning I'm happy, it's cool, or you're so bright that you're blinding me. All right, awesome. Saima, you're a hero. You're my hero. Okay, great. We have the perfected, well, perfectly working. Not necessarily the best version of the code, but it's perfectly working. So we can get rid of that. Yeah, okay. Yeah, awesome. And in fact, I'd like to condense this a little bit to see that the flush is kind of after. Whoops, let's do that. There we go. Oh, look at that. That even lines up. That's kind of cool. Term out row, we're flush, term flush. Yeah, so much more readable. That looks nice. All right, so we cut down the byteage a little bit here. I want to walk through. Should we walk through all of this? I mean, people watching, I'm sure you know BQN better than I do. So we'll just quickly walk through this. Okay, so we start out by assigning -1 to count. We get the arguments. Args is a system function that gives us the arguments, and unlike GNU APL, it's not this combined line of you've got to find the user arguments. I believe they're only the user arguments, just like in Dialog APL. We're doing a concatenate of blank to the end because this could be empty, nothing. And then we're taking the first, this little guy here. Sorry, I'm having to remember what I did, but I believe it's it's like the shoe. Let's see if we got the shoe in here. Actually, let's just copy. This is the right shoe. So right shoe. Yeah. That's used in a couple places. There it is. And that's this operator. So pretty much the same thing. It just gives us like we could copy this into BQN pad. Probably because .args is not available in BQN pad. But if we wanted to, we could put some args in here. Could say these are args, and we get the T. Why do we only get the T? It's a little weird. 2, 3. Interesting. But here, oh, of course, it's a list. I mean, it's an array. It really is. It's an array like this. That's what it is. This is what we're getting here. Yeah. Yeah. We don't need the rest of this. That's it. That's right. It's giving us the first element of the array, and that's why I'm appending an additional element here, because if this is empty, and I guess the notation for doing an empty array would look like this. No, empty array would be that. Because if we don't do the append, what do we get? Exactly. So just in case we get an empty array here, we're actually appending an empty element to produce the string of nothing. And that's what we're testing against. Okay, that makes sense. Right. And we did similar logic over here. We actually appended a -1, and this was because we were using the count value as a determinant of whether or not the argument was there. And if there are no arguments at all, we're going to have the same problem. So it's always going to grab the first argument, and there's always at least going to be a -1, even if it's empty, and then it assigned a -1. You can see here it says, look, if it's not -1, we got something. But if it's a -1, because we appended -1, we end up on countdown. This could have been something else. In this case, instead of using count, instead of actually assigning it, we just append this empty string to input, and then we test for we're blocking up this loop based on count. We're going into this loop no matter what. So this instead of a while, this is really a do while, because we need to we need to either ask for the input and then convert it to a number, or we have the input from the argument, we still need to convert it to a number. We're always going to enter here. So that's why this while loop depends on the count -1. So this while loop is a special BQN control structure, control flow structure. He has described, Marshall has documentation where he describes a lot of different ways to do typical control flow. Now notice we're not creating a function in which we have go-to arguments, and we're using simple if conditionals. You know, if it's not a -1, go to check, right? Skip the prompt because we have it from the argument. Here we're actually going into a loop, and we're saying, let's execute the loop if our count is -1. Count's always going to start -1, so always going to be doing. But the reason why we're using this while is, this is not really meant to be a BQN tutorial, and not qualified to do that. You're best off going to all the great documentation on the website and going through it. But one of the things he does talk about is how to do control flow in the more functional and array style using operators. But in this case, there are a couple of ways to do while, but the way that he shows how to use doing while with just operators doesn't provide the guarantee of tail call optimization, which means you could blow out the stack. This particular system function, as you can see, it's a system function, specially named, ensures that if this while loop goes eternally, I'll say infinitely, but eternally, this is the halting problem. There's no guarantee this is going to halt, right? The user just keeps entering the wrong thing over and over. As long as the user keeps entering the wrong thing, this program is never going to end. It's a program completely dependent on getting correct input from the user or being, abend, being interrupted, control C, whatever. In this case, this loop could go on indefinitely, and using the normal operator control structures, you have the possibility of using up stack on each iteration. This while system function is guaranteed within BQN to not have that problem. It iterates with tail call so that you're not burning up stack while you're doing that. And I thought that made sense to use. This is that guy there again that Zyma had us use as an argument to flush. So flush obviously takes an argument. In this case, the argument is nothing, and that nothing causes it to execute properly. I think it's the same thing here. Now, the difference between APL is in APL, the arguments to these defense. So the braces also define a defense very similar to APL, right? It's an immediate function. This is a function that's immediately defined, anonymous function lambda. But rather than using alpha and omega, Marshall chose to go with this stylized X, which actually resembles more math. When you see functional programming matching math, right? You have functions are expressed as f of x. So the expected argument is typically represented as x, and that's what we're seeing here. But because all functions and operators either take one or two arguments in BQN, he decided to make the second argument w, or because it seems kind of weird, why would the second argument be w and not y? In math, you would typically see, x and y rather than just x. I could go through the documentation, and don't get me, I could be wrong here, but I believe it was more of a positional thing, that because it's parsing from right to left, single argument operators and functions, the x is on the right, and if it's a binary operation or function, the second argument's on the left. And alphabetically, W comes before X, right? W, X, Y, Z. So if you were looking at it saying X and Y, but Y is to the right of the alphabet, but it would be to the left in the expression. I think that's the reason why he went with W. And I was a little confused by this at first because this little W looks a lot like the W-ish of omega, but it's not meant to be omega, right? So alpha and omega is alpha's first on the, right, first, same logic, right? alpha is the leftmost character in the Greek alphabet. Omega is the rightmost character in the alphabet. And so it kind of matches up left and right. When you're looking at alpha, you think, oh, that's the left argument, and omega is the right argument. In this case, he's saying x is the right argument, and w, the character that comes before x, is the left argument. That's my take on it. I believe S is the function that the context of the function we're currently in. Here we get that diamond operator. So what we're saying is here, this is a little bit fun. This is part of the somewhat sophisticated syntax that the document. Let's just go ahead and look at the documentation, because this is particularly important here. He has it in control flow. Let's reinvent control structures. Here we go. This is it here. I'm very impressed by Marshall's documentation. There's a lot of it here. He really goes deep and onto the whole rationale for BQN and why he made every choice that he did. So yeah, it's control flow and BQN. By the way, that episode that I pointed out addresses this quite a lot. So this is really worth a listen. Whether you're APL or BQN, you're going to hear Marshall talking about his approach. Adám talks a lot about the APL approaches. Bob talks about J, being their areas of relative strengths or greater strengths, expertise, whatever you want to call it. So this is invaluable, listening to this particular episode about this. And then in BQN, reading this. And here's where Marshall shows the different equivalents to what we'd see as statements in imperative language, or in the case of, we saw in Adám's dialogue, his first dialogue example, where he shows structure. We see that they actually provide this kind of traditional English word imperative style thing, and I think we're seeing sort of the equivalents here. But Marshall's saying this is how you would do it in BQN, and he explains the different variations. And here we're saying, look, if you use while to run forever, you really want to use this one, because this while has that stack issue. If your while loop is going to be a small number of times, then this might be safe to use. But if it's indeterminate and it's possibly eternal, you're going to want to use this while. And he describes a lot of that down below here. Rather than walking through the syntax, he's kind of showing how this works out as a way of stranding functions. I don't think I'm going to go through all of the details. I point people here to try to understand it a little bit better. It made sense to me at the time when I implemented it, because I read through this and it makes sense, but it's subtle. I'll put it that way. It's subtle. But as you can see, he formatted it in such a way that it resembles what you would see in a block-like structure. And I followed that same kind of idiomatic formatting. So it kind of looks like while, condition, execute. But these are really two direct functions. These are two lambdas. This is you can see this is a lambda in of itself stranded to another lambda. So we're seeing an array of lambdas being reduced based on this lambda. So each of these functions, one of these is the condition that gets evaluated, which would be on the first pass. It's going to be x. I can't remember whether x is in the reduction or whether x is the accumulator. Pretty sure the left argument, the left argument is the new element in the reduction. So this first element becomes the condition, W, and the second becomes what we execute while we do it. That makes sense. Anyway, you can dive more into the details to understand it. The rest of this is pretty straightforward. We come into here and we basically say, look, if input is not equal to blank. So remember, if we didn't get an input, in other words, if we didn't have any arguments passed to us because we appended this empty string to the end, because you're not going to get empty strings in arguments, right? It's all white space separated. So if there's nothing there, it's not going to give you an argument. It's only going to give you argument values where there's actual text entered in the arguments. And it's the separate arguments come in as separate strings as we saw stranded together. You're not going to get an empty string as an element in the args. We saw what happened, right? We just get an empty list. So this is a safe way of looking. I can add an empty string. It's still a string, but it's a string of nothing, which isn't the same as nothing at all, right? Nothing at all in the array is an empty array. This is an array with one element that is an empty string. And we only get that if we append it here. So we know that there were no arguments, and we're going to prompt here for the countdown. So that's pretty simple. We got a nice ternary operator, which is really great. So even though we've got more complex expressions for the other forms of control flow, while, switch, he shows that you've got this this function and operator based way of doing if and if else, but very conveniently you can avoid this entirely by using the ternary if operator here. And the way it works is, of course, condition, if true, it executes that, else it executes what follows the semicolon. I know this is a little backwards, but it's basically saying, if true that it doesn't equal this, do nothing. This is the do nothing. Is it an operator? It's not a modifier. Maybe it's a value, maybe it's a special value. We'll look that up and see what that is. So if we don't get that, we're going to do the countdown. We're going to do the get line, and notice the get line also has the nothing on it. Actually, I like that it's attached like that. Let's do that. So get line. Yeah, these system functions that don't take arguments still require. It looks like that's what they were saying. They require kind of a nothing argument to operate properly. So we come down here, again, we're checking input because it's possible that nothing could have been inputted here. So we're saying if the input is not null, and, this is the same and as an APL. We're doing the shoe again, or what is it called? I don't remember if he's got a name for it in BQN. But we're taking the first, and this is that same expression we saw over here, which is, are you a digit? And that was the one thing I wanted to look for. We'll worry about that later. We could probably optimize this out, and there's probably a digit function, are you a digit? And maybe a simpler way to collapse this, and a way to introduce some kind of combinator. I mean, I don't like this. Input, 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 input. Connor has effectively made me a big fan of combinators. So I would like to see some tacit in here. Yeah, like input, input. Like how many times does that show up? Arg. And then how many times does count show up? Yeah, so I'd love to do a tacit version of this, but I'll save that for another time. So yeah, if we're not there, what do we do? Oh yeah, if we are. So we have something was input. It's all digits. Now we can do it. That's an if condition. We can safely call the evaluator to evaluate that. That's the shortcut to the harder work. It's done by the fire hydrant here. Else we got an invalid countdown. We show the input. We say try again. And we reset the input back to an empty string so that we will, when we while, we come into the loop here, the while is gonna, so our count never got assigned, right? So our count is still -1. This count will never be assigned until valid numbers are put there. So it's gonna stay -1, the while is gonna continue, but we do need to reset the input. Otherwise, we would bypass the prompt here. So the prompt is depending on, we show the prompt if it's input. If we don't do that, it's not going to show the prompt, and it is going to go into an info loop. So this line is critical. Now, what's interesting is, it would be funny if we tested this, because in theory, this will not blow out the stack. So let's see what happens if we don't do that and we put invalid input. Let's move this over. Let's see what happens. FUD. It's going, it's going, it's going. Well, it's not blowing out the BQN stack. At some point, it'd be interesting to see if RAM is dropping. Let's see what happens. Let's go up here. Memory. Let's see what we got. Who's using the most memory? OBS is running, obviously. I don't like BQN's using much memory at all. Look at everything else. Probably one of these terminals. Well, I can't even tell. It shows you how memory efficient it is. Look at everything else. Windows Server, Windows Server. Ugh. LibreOffice, I don't even know why I'm running that. It's force terminate. Yeah, I don't even know if I see it in here. Let's do name a process. I don't think BQN is going to show up as a named process here. Oh yeah, look at that. Oh wow. Okay. That's kind of cool. I would think we'd be seeing this slowly creep along. Statistics. Oh, sorry, this is all in Portuguese. So to force myself to learn the language, I'm working on becoming a citizen of Portugal. I put all my devices into Portuguese in English, Portuguese, and Portuguese. So I can't use my devices without at least understanding what half of these things say. All right, well done, Marshall and Zyma. That's cool, right? Halting problem. This thing ain't never gonna halt. So let's interrupt that. Cool. This is neat. All right, I think we know how the rest of this works. We already know we got the solution out raw. We got the flush format. This is just taking our number. Or what do we do? What do we do here? How is this working? Oh, yeah. Just like the APL version, pretty much the same. All right, let's put that here. Reading from right to left, we take the count. Instead of iota, BQN uses this, I think it's called range, the up and down arrow. Does the same thing. It generates an array from 0, I believe, because it's 0-based index. So that's why our x is +1 here. And over here, our omega is just straight up, because iota is going to give us a 1 to count array. Range is going to give us a 0 to count -1. We are reversing it because we want to count down from the end. We've got a each or for each. So for each element from whatever the count is, we execute this entire defense, same way it's happening here. Curious to see if Adám did it the same way or simplified it. It looks pretty similar. Did he tune it up even tighter? Looks like it's similar here. We've got an iota. Yeah, so we can see right here tacit, right? Where I'm using count and count, right? Intermediate variable. He structured this in such a way that going from right to left, from the input arguments or the input, we're getting tacitly the argument passed all the way down, and it becomes, after the execute here, we're saying we execute this. This was the string. We get the iota of that value. So yeah, this is nice. It's long. I would still break this into multiple lines. which I think we could do just by getting rid of, yeah, we could just get rid of these, the diamond, because this is a statement break here. Yeah, each of these is a statement break, I think. Yeah, these are independent statements. Well, these are statements within a defense. Is this all within a single defense? Oh, it is. I think that's okay. I don't have dialog installed, so I can't test this, but I'm assuming I could break this at the diamond here. Because this is bracketed by the defense here. So we could break this at each point. But the whole point Adám was making was we could do this in a single line. Still cool. So yeah, so otherwise it's the same logic. We're gonna, now remember, we're evaluating when we have multiple statements within a defense, separated by these diamonds that you can barely tell is a diamond, not anybody's fault but the font that I'm using. It's going to evaluate each expression from left to right, but in each statement from left to right, but each expression is going to evaluate from right to left. So we're going to execute this first. We're appending the ... That's a concatenate or append. To formatted this, we output it to raw. Format is converting our number to a string for us. And over here, I think our number to string is converted by Thorn. Is that Thorn? I mean, what did Thorn do? I'm guessing that the monadic version of Thorn is going to also convert that to a this is format. That's right. So BQN uses FMT as a system function or built-in. I'm not sure if it's considered a system. That's probably just considered a built-in library function. It's called Thorn, right? It's the opposite of the upside down hydrant. This is format. So this is format this in a way that can be sent to output. That's our quote quad. Here we got term out raw. Then we need to flush it. The flushing isn't required on the GNU APL side, nor the dialog APL side. Looks like the flushing is automatic. Dialog works perfectly, but GNU, we have a problem with input not being echoed, so it's still there. We do the delay system function. Over here is a DL, it's quad DL. I believe it's the same in dialog. Yes, we're seeing quad DL. And then we exit 0 instead of off, and that's it. That's it for CBQN. All right, this is a pretty long thing. Well, it's over an hour. I can edit this down. I mean, why is there a time limit? Any folks, anybody watching this, you just jump ahead, fast forward. That's why I don't object to long videos. People are like, long videos are bad. It has to do with monetization. I don't care about that. And if you don't want to finish, you can stop at any time. You can fast forward and do whatever. I should add little chapter title headings, but great. That's the BQN version. We have a nice success. We'll be saving that. Let's run it one more time. Make sure it runs. Hooray. Countdown 4. 1, 2, 3, 4. Excellent, excellent, excellent. Okay. I think that's it. I hope you enjoyed. Hi to everybody out there. And thanks again to Zyma for helping solve the problem. This has been proglangcast. I'm one of your hosts, Christopher Augustus. The other host, Steve, will be back next week. And I don't know if he'll be ready with F#, but I've already implemented Bye Bye Hello World in Shea Scheme, Racket, and S7. And if he's not ready with F#, we'll go through those. Until then, in all your adventures in BQN, APL, array languages, and any other programming you do, I wish you the best of luck.